Imagine, for a moment, you're not alone in the universe. What if there's a planet just like Earth somewhere far away? A fascinating thought, isn't it? The universe we live in is an intriguing place filled with a myriad of mysteries waiting to be unraveled. As we gaze at the night sky, the stars we see are just the tip of the cosmic iceberg. Our universe is vast, almost unimaginably so. It stretches beyond our wildest dreams and comprehension, a swirling mass of galaxies, stars, planets, and what we've come to know as dark matter. This vastness is both awe-inspiring and humbling. It reminds us of our place in the grand scheme of things, and at the same time, it sparks a curiosity that's quintessentially human. Now let's ponder a thought. Could there be a planet out there somewhere in the distant cosmos that's similar to our own Earth? A place that harbors life as we know it? The possibility is not as far-fetched as it might seem. Our understanding of the universe and its workings has grown exponentially over the last few decades. And with this understanding comes the realization that the conditions necessary for life might exist elsewhere. Consider this. Our galaxy, the Milky Way, is home to billions of stars. Many of these stars, much like our Sun, could potentially have planets orbiting them. And among these planets, there could be those that lie in what scientists refer to as the habitable zone. This zone, often called the Goldilocks zone, is the region around a star where conditions might be just right, not too hot, not too cold, for life to exist. It's a tantalizing thought, one that has captured the imagination of scientists and laypeople alike. The search for Earth-like planets and the possibility of extraterrestrial life has become a cornerstone of modern astronomy and space exploration. As humans, our curiosity and thirst for knowledge have led us to uncover some fascinating truths about our universe. But there's still so much more to discover. So let's delve into that. Let's embark on a journey to understand the universe and our place within it. To understand the potential for life on other planets, first, we need to understand the concept of habitable zones. Imagine a star, radiant and pulsating, the beacon of life in the cold expanse of space. Orbiting this star, we find planets, each in their unique dance around their sun. Some are too close, scorched by the star's fierce heat. Others are too far, trapped in an eternal winter. But somewhere in between, there's a sweet spot, a region just right for life to exist. This, my friends, is what we call the habitable zone. The habitable zone, also known as the Goldilocks zone, is a region around a star where conditions might be just right for life. It's a place where a planet is neither too close nor too far from its star, allowing liquid water, a vital ingredient for life as we know it, to potentially exist on the surface. But why is this concept so important? Well, our search for life beyond Earth hinges on finding planets in these habitable zones. For us humans, life means water. If a planet has the right distance from its star, it could maintain stable liquid water on its surface. And where there's water, there could be life. This doesn't mean that planets outside of these zones are barren and lifeless. Life, as we are discovering, can be incredibly adaptable, and there are theories of life existing in the most extreme environments. But the habitable zone gives us a starting point, a guidepost in our quest to answer the age-old question: are we alone in the universe? As we peer into the cosmos, with our telescopes tuned to distant stars and their planets, we search for those precious Goldilocks zones. Each discovery brings us one step closer to finding a world like ours, a world that could harbor the miracle of life. So, in essence, habitable zones are cosmic Goldilocks zones, not too hot, not too cold, but just right for life as we know it. Armed with the knowledge of habitable zones, scientists are on a relentless pursuit to find Earth-like planets. Our understanding of the cosmos has grown exponentially over the last few decades, and with it, our curiosity. We've set our sights beyond our solar system, venturing out into the vast expanse of the Milky Way to find planets similar to our own. Not just for the sake of discovery, but also to answer the age-old question: are we alone in the universe? This quest has led to the launch of missions like Kepler and TESS. both of which are dedicated to finding planets outside our solar system, known as exoplanets. These missions have been wildly successful, with Kepler alone identifying over 2,000 confirmed exoplanets, and TESS expected to find thousands more. So what makes a planet Earth-like? Well, it's not just about size. An Earth-like planet is one that orbits a star within the habitable zone. It's a region where conditions might be just right for liquid water to exist on the surface, a key ingredient for life as we know it. The planet should also have a rocky surface like Earth and an atmosphere capable of sustaining life. But it's not as simple as it sounds. Detecting these planets is a bit like trying to spot a firefly in a sky full of fireworks. They're incredibly small and faint compared to the stars they orbit, making them difficult to observe directly. That's why scientists rely on techniques like the transit method, which involves observing the tiny dip in a star's brightness when a planet passes in front of it. Despite these challenges, our pursuit of Earth-like planets is far from over. In fact, it's only just begun. Each new discovery brings us one step closer to potentially finding life beyond Earth. It paints a picture of a universe teeming with possibilities, full of planets that could be just like ours. The search for Earth-like planets is more than just finding a new home. It's about understanding our place in the universe. You might ask, why all this fuss about finding Earth-like planets? Well, the answer is quite profound. The search for Earth-like planets, or exoplanets as they're often called, is not just about satisfying our curiosity. It's about exploring the uncharted, unraveling the mysteries of our universe, and pushing the boundaries of our knowledge. Each discovery is a piece of the puzzle, helping us understand how planets form, how they evolve, and what conditions might lead to the emergence of life. But it's not just about answering existential questions, it's also about the survival of our species. As Stephen Hawking once said, "I don't think we will survive another 1,000 years without escaping beyond our fragile planet." The Earth has a finite lifespan, and so do we. One day, our sun will run out of fuel, becoming a red giant and engulfing the Earth. In the face of such eventualities, finding another suitable home becomes a matter of survival. Furthermore, the search for Earth-like planets feeds directly into our technological advancements. It challenges us to develop new tools and techniques, to innovate and adapt. The pursuit of these distant worlds has already led to developments in data analysis, telescope technology, and space travel. Who knows what other advancements lie on the horizon? The search for Earth-like planets also has cultural implications. It forces us to broaden our perspective, to see ourselves as a tiny part of a vast universe. This cosmic perspective can foster a sense of unity, reminding us that we share this planet and its future. And finally, it's about hope. The possibility of finding a planet with conditions suitable for life, or better yet, signs of existing life, gives us hope. Hope for the future, hope for survival, and hope for the incredible possibilities that our universe may hold. The search for Earth-like planets isn't just scientific curiosity, it's a quest for our future. The universe is vast, and the search for Earth-like planets is like finding a needle in a cosmic haystack. But we are not deterred. We are explorers, pioneers, and innovators. We are constantly pushing the boundaries of what we know and venturing into the unknown. The future of space exploration is full of exciting possibilities. As our technology advances, so does our capacity to explore the cosmos. We are already seeing the development of new instruments and techniques that could revolutionize our search for Earth-like planets. One such development is the concept of megastructures. These are vast, artificially created constructs that could be used to harness the energy of a star, or even to create habitable environments in space. Imagine, if you will, a structure so large that it could encompass a star, capturing its energy and using it to power a civilization. This is the concept of a Dyson sphere, and while it may sound like science fiction, it is a possibility that scientists are seriously considering. Another exciting development is the advent of faster-than-light travel. While still firmly in the realm of theory, the idea of being able to traverse the vast distances of space in a fraction of the time currently required is a tantalizing one. It could open up new avenues for exploration and could potentially bring us closer to discovering Earth-like planets. Then there's the prospect of artificial intelligence. AI could play a crucial role in our exploration of space, aiding in the analysis of data, guiding spacecraft, and even making decisions on our behalf. It could be the key to unlocking the secrets of the universe. These are just a few of the exciting developments on the horizon. The future of space exploration is a thrilling frontier full of potential and promise. So, as we gaze upon the stars, remember, we are not just looking for new worlds. We are searching for a better understanding of ourselves and our place in the cosmos.